Boeing versus Airbus. You see the names and you probably think, hey, they're just two massive companies building similar planes, right? But what if I told you that underneath the paint and logos, there's a deep, fundamental clash of philosophies? We're talking about completely different ideas on technology, on control, and even on the role of the pilot. So let's peel back the fuselage and see what really makes these titans of the sky so different.
So what is the real difference then? I promise you, it's not about the shape of the windows or the legroom in coach. The things that truly set them apart are kind of hidden in plain sight. It's in the way the pilots fly the plane, it's in the very materials the wings are made of, and it's in this invisible tidal wave of data that's constantly flowing from the aircraft. Just take a look at this. On the left, you've got this explosion of dials, gauges, and levers. It's a maze. And on the right, clean, sleek digital screens. A glass cockpit. Now, this isn't just a simple design refresh. This is a full-blown revolution. And it's right at the heart of our story, because it forces us to ask a really big question: who or what is actually flying the plane? And that brings us right into the digital cockpit. This is about so much more than just some fancy screens. It represents a total shift in the relationship between the pilot and the aircraft, and it sparks the one debate that truly defines the whole Boeing-Airbus rivalry. Is the technology a co-pilot, or is it the ultimate guardian?
The core technology that makes all of this possible is called fly-by-wire. So think about it like this. Old planes were like giant puppets. The pilot pulled a yoke, and a whole system of physical cables and pulleys would move a flap on the wing. With fly-by-wire, that physical connection is gone. Now the pilot is more like a gamer with a really advanced controller, sending digital signals to a computer, which then decides how to move the plane.
And here's basically how that works. It's a simple chain of events, really, but with massive consequences. 1. The pilot makes a move with the controls. 2. The flight computer, the brain of the plane, reads that input. 3. It zaps an electronic signal down a wire. And 4. A little robotic motor, called an actuator, physically moves the control surface on the wing or tail.
Okay, and this right here, this is the fork in the road. This is where the two giants, Boeing and Airbus, look at the exact same technology and come to two totally different conclusions. Because once you put a computer in the middle, you have to answer a critical question. How much power do you give it?
Boeing's philosophy is crystal clear. The pilot is the boss, period. The computer system is there to help, to warn, and to guide. It might even make the controls feel heavy to give the pilot a heads up, like, hey, are you sure you want to do that? But it will never stop the pilot. In a Boeing, the human always has the final say, even if the computer thinks it's a terrible idea.
Airbus, on the other hand, sees it completely differently. Their system creates what's known as a flight envelope. The best way to think about it is as a digital safety bubble that surrounds the plane. And as long as the plane is operating under what they call normal law, the computer will simply not allow the pilot to fly outside of that bubble. It won't let you bank too sharply or pitch the nose too high and risk a stall. The philosophy here is that the computer is the ultimate safeguard against human error in a moment of crisis.
But listen, these differences aren't just in the software. They are literally built into the structure of the planes. And that brings us to the second massive revolution we need to talk about, the game-changing shift away from aluminum and towards advanced composites.
53%. Just look at that number. What do you think that represents? It's not a stock price, it's not a market share. No, this number represents a profound change in the very fabric of how we build modern airliners.
That's the percentage by weight of the Airbus A350 that is made of composites. And Boeing's 787 Dreamliner? It's right on its tail, at a staggering 50%. This is not some fringe experiment anymore, folks. This is the new gold standard in aircraft manufacturing. So why make the change? I mean, what's wrong with good old aluminum? Well, it comes down to two things. Composites are both stronger and lighter. That's the magic combination. This allows engineers to design things they could only dream of before, like these incredibly long, slender wings you see on the right. These are called high aspect ratio wings, and they are ridiculously efficient, slicing through the air with way less drag.
This chart right here tells the entire story. Just look at those massive bars for the A350 and the 787, the planes designed from a clean sheet of paper. Now compare that to an updated older design like the A320neo. It makes it obvious that when you're designing the next generation of aircraft, composites aren't just an ingredient in the recipe, they are the recipe.
And the final result of all this high-tech manufacturing? Well, it's a whole new breed of airplane. They're lighter, they're stronger, and they sip fuel instead of guzzling it. That's a huge win for the airline's bottom line, and honestly, it's a pretty big win for the environment too.
So you've got these incredible machines built from space-age materials. But what happens when they need maintenance? That brings us to our third and final revolution, the rise of the smart fleet, where planes have stopped being just flying machines and have started becoming flying data centers.
Okay, so here's the nightmare for any airline. A modern jet has miles of wiring crammed into it, so finding one tiny little fault is like trying to find the one burnt-out bulb on a string of Christmas lights long enough to wrap around your entire city. This one tiny problem can keep a multi-million-dollar jet stuck on the ground for days, losing a fortune.
This is the classic before and after. The old way was just a brutal, painful process of elimination. Technicians manually checking wires, swapping parts, hoping they'd get lucky. The new way? It's like having a GPS that leads you directly to the problem, pinpointing the exact location of a fault in minutes, not days.
And here's one of the brilliant tools that makes it happen. It's called SWITS, and it uses a technique called reflectometry. Think of it like a sonar. It sends a tiny electrical pulse down the wire, and then it listens for the echo. Any break or short in the wire changes how that echo comes back, allowing the tool to calculate the exact location of the fault. It is absolutely genius.
Airbus has taken this data-driven idea and built it into a whole maintenance philosophy called Optima. You see, the old way was to fix things on a rigid schedule, kind of like changing your car's oil every 3,000 miles, whether it needed it or not. Optima uses data from the entire fleet to move to a much smarter model. Fix it when it actually needs fixing. It's cheaper, it's more efficient, and it's safer.
But the ultimate goal, the real holy grail here, is to see the future. Systems like Airbus's AirThem are designed to shift maintenance from being reactive to being predictive. They crunch a constant stream of data from the plane, looking for the faintest digital whispers of a future problem, so a part can be replaced before it ever has a chance to fail.
So, let's put it all together. You have smarter cockpits, you have lighter and stronger materials, and you have predictive maintenance that can see into the future. What happens when you combine all three of these incredible revolutions? Well, you get a pretty clear picture of what tomorrow's aircraft are going to look like.
The future is really a fusion of all these ideas. Imagine planes built with exotic designs like a blended wing body, constructed from these advanced composites, guided by intelligent computers, and constantly watched over by a predictive AI. This isn't science fiction anymore. This is the actual roadmap for a new era of aviation that's safer, smarter, and more sustainable than ever before.
And all of this, it brings us right back to that first big question, the one that started this whole thing. As these planes get smarter, as they become more and more autonomous, what happens to the human in the cockpit? What is the future role of the pilot in an increasingly automated sky? That's the fascinating question we're all going to have to answer.